Welcome to Let's Make a Game Platformer, episode 5. In last episode I've shown you how you can load levels from a JSON file. I've right now just also modified this to for this level to be not exactly the same. So I modified the level of the platform to be a bit higher for the level sample one. And this is because I'd like to fix the way the levels are loaded. So whenever a level is loaded, I want to make sure that the old one is unloaded. So let's maybe start with that. We'll extract this as a level loader class, and level loader load level sample. So the problem now is that when we run this, we will see only the first level, even though we should be seeing the second one, because once the terrain is... No, we will not, because the render method is called later. Anyway, but the problem is that we are creating two different terrains, and we are not disposing the old one whenever we create the new one. If that makes any sense, if we're going to be uploading it later on. So how we actually can achieve this is that we want to initialize the terrain whenever the level is loaded. And the way we do it is using the events that are introduced by the ECS that I wrote. And there is one of the events that we are interested in is after component is added. So we are interested in a level component. So whenever a level component is added to an entity, this event is fired. So now we can get rid of this, because we no longer have to extract the level, because it's given to us in the parameter. And the way we ensure that this method is called whenever actually this event is fired on an entity is by using receive event annotation. So what we do here is whenever this event, and this event is fired internally by the ECS, I'll show later how to create your own events and how to fire them. So whenever this event is executed on an entity that has a level component, in this case these events that are associated with components are actually very special, so this event is going to be fired only if the level component was added. So something that had a level component before, some entity that didn't have the level component before now has this component. And per analogy, we will have void level unloaded, so before component removed. So before it will be removed, we will be doing model dispose, model null, terrain null, and this no longer has to be here. Instead, what we'll do that if there is a terrain, we will render it. Excellent. So now we can extract this to a method. Destroy terrain, and call this method also here. However, we should make sure that this is called only if model is not null. So if it was already disposed, we don't need to do that. Okay, now how do we ensure that? How do we enable this annotation? The way we do is by enabling this profile, annotation event dispatcher. So basically this event dispatcher is listening to entity events, and it calls all the systems in the context for any methods that have this annotation and are in the form of event as a first parameter, entity as a second parameter, and a number of components as a subsequent parameters. So we have to enable it here. And so We just want to make sure that this is called, so we will debug it here. And when we actually run it, oh, it was not called. Wonder why? Because our level system does not destroy the previous level. So what we'll do here is we'll store the level entity here. And if it's already exists whenever this method is called, we'll do entity manager destroy entity level entity equals null. Okay, now that should work. So whenever second time this method is going to be called, it will clean up the previous entity. Okay, so this is called now. We'll step into this one. We are disposing the model and terrain, and we are correctly seeing the second level that is being loaded. Excellent. So now we fixed the level loading a bit. So let's now maybe... So at the moment we have terrain rendering, but we do not have a rendering for player, so player's character. So maybe let's start with something that's gonna be creating the player. So let's create here a package player and do a class player system. We will register it. And let's go with we want to create a new interface here. It's gonna be player manager. Create player. It's gonna have me to create player. This one's gonna implement the player manager. We now have to remember to make sure that this system actually shares the interface with anything that uses this context. And in here we will implement a method create player. So what we're gonna do is we're gonna create a new prefab, player prefab. For now we'll make it an empty one, so it will have no components. We will just create using entity manager and prefab manager. We will say prefab manager give us get prefab by name player prefab, and then we will do entity manager create entity player prefab. So now we have a player prefab that is going to be created. We have to now invoke this, of course. We'll do this before we load the levels. So let's do context get system. We have to remember that our player system was sharing player manager interface, not player system, so we have to look for player manager create player. Okay, let's make sure that everything's working correctly. Okay, it's not crashing. It doesn't do anything, the player, because at the moment the prefab itself is empty. So what we'll do here is create a new, maybe package component, and create a new component which will represent the location of the player, or location of anything actually, and depending what it is associated with, it's gonna be different. It will have different meaning probably. So location component, we have to remember it's an interface and it has to extend the component interface, and in here we'll create a couple of methods. First of all, we'll do float get x, void set x, float x, float get y, void set y, float y, float get c, void set c, float c. Okay, so we have the methods for the component, and let's add this component to the player prefab. So we'll do location component, and it has x of 0, y of 0, and z of 0 as well. Awesome. So we now have a player that has a location component. Let's make sure everything's still working. There will be no effect on the game itself or visuals or anything, but we have to make sure that it doesn't crash in any way. We didn't miss anything. Yeah, everything's fine. Okay, so now let's create a character component. And the character component, maybe don't call it character, let's call it character render component, which basically, it's going to be an interface, of course, as every component is in my ECS. So it will have a couple of things. First of all, it will have read-only ID of the character. It will have a read-only shape. We'll just use the same. Well, as I said before, in this sort of series, I do not care about graphics that much. I just show how to do stuff. This could be easily replaceable by some more complicated models, and this one's going to be very similar to block component. It will have textures, and we'll just use the block to render a character. Okay, texture for parts, shape, and ID. I'll show why the ID in a moment. So what we'll do here now, so we have a character component or character render component. We will add it to player prefab. Our player prefab will now have a character render component with ID of player, with shape of cube, and let's copy it's gonna look like a stone. Let's go with that. Okay, so this is our component. Our player now has something that renders it, and what we're gonna do here is now a renderer for characters. Character renderer. It's gonna implement an environment renderer. We have to register it, and what we're gonna do in the method, we don't care about the lights for now, we'll just skip this, ignore it, and in here we will have a list of model instance. or maybe no, let's go with a map of string to model instance, models, and model instances, and map of model models. Okay, so what we are interested in now is, once again, we will receive event, character added, after component added, character render, event, entity, and we are interested that this entity has to now have both character render component as well as location component. So in this case, what we want to do is extract the ID of it. This has to be unique, and we will copy the code here. We will not copy it, it's not easily copyable. So let's do character render get shape name. We will inject shape manager. It's not called shape manager. What is it called? Shape provider. Ah, yes, it just provides, it doesn't allow us to modify them. Shape provider, and texture atlas registry and texture atlas provider. So we will do shape name, shape provider get shape by ID. So let's name it, maybe let's just inline it. Character shape, and we'll do array vertex output and shape output. Array vertex output, character shape. We'll copy this from here. Oh, I can copy the whole thing here. And instead of this, we'll have character render, get texture parts, and characters. It's gonna be the stuff, and the location is gonna be, once again, location get X, location get Y, location get Z. Not this. Don't need this here, we have it already extracted. Awesome. And then we will just copy this part. Array vertex output, create character part, get texture characters, and we'll add this model to models, put character ID model builder end, so here, and model instances add put, sorry, it's a map, character ID, new model instance of model, awesome. So we have them both. Actually, no, let me fix this part, because it will be modified all the time. So we have to do the inverse of character removed before component removed, even the we'll go and character render get ID, character ID, we will model instances remove character and models remove character ID, but on this one that is being removed we'll have to go dispose, so we have to dispose of the models. Okay, and now in here this is going to be easy. We'll go through the, first of all we have to create a model batch. And we will do a model batch. So if model instances it's not empty, so if there's any characters to render, we will first of all model batch begin, passing the camera, model batch end, and in between them we have to pass the render model instances values, so all the characters. That's not everything. First of all we have to make sure that the characters are where they are supposed to be, so we have to move them by their location. The way we'll do this is we'll have to iterate through all of them in this system and make sure that the model instances are actually correctly positioned. We could use entity manager for this to iterate them, but this is very slow and should not be used if you are going to be doing this a lot, and we'll be doing this a lot because we're going to be on every rendering we'll be getting through all of them. So what we can use instead is entity index manager, and in the initialize method of the entity index manager we'll add an index. So we want to be able to say that I want to go through all the entities that have this component and this component. Let's add it as a field, characters index. So in here we'll go through characters index, we'll iterate through them, we'll extract the component, the character render component, we will extract the location component, and we will make sure that we get the model instance for the character, and on it, so we will have model instance, and on the model instance we make sure we have matrix for import it, translate it by location get X, location get Y, location get Z. Okay, so what this loop is going to do is going to go through the index, which contains all the entities that have both of these components, and we'll extract the model instance for that character and make sure the transformation is correct with the location that is here. So, is that everything? No, that's not everything. We have to register the environment renderer. It's going to be an environment renderer registry, and we have to register environment this. Let's see if that works. No, something didn't work. Aha! Entity index manager, probably have to add it to our profiles. Let's see if it works now. No. We still do not. I forgot to register the textures. So what we'll do something similar to our block texture atlas creator, where we will be just doing it in one class instead. So you have to use prefab manager here. We have to find all prefabs with character render component. We need an entity manager. And we want to use this one instead, and the name of the texture is characters. Let's make it a static and name it characters texture name atlas ID characters atlas ID. Okay, so we have it here. Okay, so that should hopefully work now. Let's see. Okay, we have something here. Was it a stone? Yes, it was a stone. Okay, so now if we modify the location of the player, let's move it to the right 2 blocks. For now we'll move it by hand. It is moved here. So this is going to be a good beginning. So we now have character rendering. That is it for this episode. I hope you will continue watching the series. Thanks for watching. Bye.